Now that we've covered KPIs of transportation management systems, we'll explore warehouse management systems. Very much like transportation management systems, a warehouse management system is a software application meant to improve the efficiencies of warehouse and distribution centers. This system focuses on the effective reception, storage, traceability, and retrieval of all incoming and outgoing inventory, while also assisting in the improvement of overall operations and allocation of resources. The primary focus of any WMS is to support warehouse functionality through constant monitoring and reporting. Optimization warehouse systems have three core objectives: improving time, flow, and storage, reducing time to complete tasks while also considering aspects of accuracy and damage control. WMSs can recognize areas where physical flow may be lagging. A warehouse should be designed with optimal flow in mind. Considering the aspects of Taylorism, which we learned about in session 3, means developing the flow of incoming and outgoing inventory by limiting the time and motion to complete the task of storage or retrieval. Finally, the right spaces for the kinds of goods you are storing are also important. Many warehouse storage spaces are becoming dynamic and flexible and can adapt to changing sizes and shapes of goods. With the right suite of systems, it is possible to have your WMS tied into your TMS. So your warehouse management system tied into your transportation management system. Keep in mind that the kind of TMS you have will depend on whether you are outsourcing your transportation or maintaining it in-house. Many operations would need to be quite large to justify the costs associated with in-house transportation management. Distribution happens when products are ordered and require retrieval from storage, also known as picking, packaging, and then shipment to complete the delivery of the purchased product. This is a core function of any good warehouse management system. Because of the variability in products and goods that can be produced, packaged, and stored with various requirements also means that there are vast options in considering your warehouse management system. So how do you choose? With so many options, you will need to consider the size of your operation, the amount of inventory you will be handling and could be handling in the future, while also considering what industry you are in and what systems are most popular among other potential stakeholders in your supply chain. Choosing a system that will easily integrate with other supply chain partners will assist in other key supply chain processes like collaborative planning, forecasting, and replenishment. To effectively compartmentalize your warehouse, it can be important to look at it as a micro supply chain of which you control. Optimizing process and flow are much easier when an organization has control and management of all systems involved. If you have a warehouse or distribution center or are planning on having one, you must consider network within it. Similar to supply chain network design, you must also design the network of your warehouse with the Taylorism approach in mind. How do you design to reduce motion and time of all tasks required to complete your warehousing practices? If the warehouse is not mapped, you will be operating in organized chaos. This will not allow your warehouse team to maintain effective KPIs and will also create disconnects between various members of the warehousing operations team. The beginning of any good warehouse map also requires the discussion of all processes involved to successfully bring in a good, store a good, retrieve it, and then ship it. If you do not focus on processes, you will create significant disconnects or unnecessary dependencies between task, technology, or process that will essentially be the end of any optimal opportunity. Just like with transportation management systems, we also have to explore different key performance indicators for warehousing and distribution. These are going to be essential for recognizing success within your warehouse efficiency. So let's take a look at a few. But again, keep in mind that these are not restrictive. You can develop your own, as success will look different for different organizations. However, these are a few to get you started. So let's look at receiving efficiency. Receiving is the first point of access to your warehouse facility. This includes receipt of all goods while simultaneously booking incoming stock. Although receiving may seem like a single point of entry and one directional downstream towards customers, the reality is your receiving is also including customers returning non-defective and defective items. This is a key part of reverse supply chain and assists in overall customer satisfaction. Good process ensures defective products are quickly shipped upstream to the vendors, or if you are the original producer of the product, the defective product either needs proper disposal or repair. Depending on your operation process, this could be done in a variety of ways. Regardless, setting a combined KPI to track the efficiency of incoming goods are essential, and this often takes the form of time taken, meaning how long does it take for stock to be counted, booked in, and ready to be restocked or redirected upstream. Time stamping process will be required for all goods. Picking accuracy. Picking is the activity of locating an inventoried good and making it available for shipment. Again, this could be up or downstream depending on the needs of the particular good. Picking gets complicated when orders require a variety of different goods and can be combined in numerous ways. An incorrect pick will also certainly result in return, which increases the average cost per unit and also impacts customer satisfaction. This is an easier KPI to measure as you simply take your total orders processed minus the number of incorrect returns and times that by 100 for your percentage. This provides your accuracy. A well-planned warehouse layout combined with an effective picking process are key to success in this KPI. Carrying costs. Carrying considers any good held within the warehouse and accounts the total cost to store and maintain the good while in inventory. This is not as simple as calculating the total volume a good takes up and then considering total overhead. Goods vary significantly and some costs are not incurred with certain goods. So cost to consider could be the cost of capital, space costs to store, equipment and software involved in the storage and picking of the good, other materials required to maintain the good in optimal state. Carrying costs of inventory can be calculated by taking your total carrying costs of all products and dividing by your total inventory value. Multiplying this by 100 will then again give you your carrying cost percent. If you're looking to improve carrying costs, look to improve your forecasting and embrace automation. Inventory turnover is the frequency in which you sell out of a specific inventoried product or your entire inventory is relinquished. The basis of this KPI is understanding how quickly a product is sold and shipped after being put in storage within the warehouse. The objective is to keep this high. If you've implemented the use of any inventory management system, this will often be calculated automatically in inventory reports. This specific metric can be improved by better forecasting and having dedicated staff to recognize slow-moving inventory and then utilizing the appropriate channels to strategize pricing incentives. Rate of return is almost self-explanatory. Essentially, this is how often a product leaves your warehouse and then returns from your customer for various reasons that could include defects, incorrect order fulfillment, or you may have an agreement to restock hard-to-sell inventory if your buyers are retail. Picking accuracy and rate of returns have a close relationship. However, different products will be impacted differently by these metrics. The key to a good rate of return KPI is to further break your returns down by reason. The reasons for return will assist you in recognizing areas for improvement. Rate of return is calculated by taking the total units of goods returned, and dividing it by the total units of the goods sold and multiplying by 100 to get your percentage. Backorder rates allow an organization to dive a bit deeper into the analysis of their forecasting and purchasing success. A high backorder rate suggests that demand is high while supply remains too low to meet demand. Demand can spike at any time for a variety of reasons. However, setting a time frame that any product can remain in backorder will assist the organization in better reaction times and improve customer satisfaction. A great example of backorder issues that are difficult to control was the impact of COVID on our supply chains. As we saw a shift in human behavior, we also saw a shift in demand for different products. While the world attempted to understand the virus and its ability to be transmitted, many warehouses were impacted based on a number of things from border crossing times to closure coming into effect of borders. Things like fridges, freezers, and other like products saw multi-month backorder rates because of the lack of control that supply chains had over the situation. Backorder rates can be calculated by taking the total number of backorders and dividing by the current total orders of the said product. Multiplying by 100 will give you your backorder percent. Order lead time works closely with backorder rates as it seeks to measure the total time it takes for a customer or purchaser to receive orders after being placed. The shorter the lead time, the happier your customers will be. A major consideration with lead time takes into account receiving efficiency, picking accuracy, rate of return, and backorder rate, as order lead times can be demolished if the order isn't available quickly for shipment, is picked and packaged incorrectly, or the quality of the product is so poor that it results in returns. As an example, order lead time with Amazon or similar business models can easily be calculated by recognizing the time stamping on when customers completed the final transaction to purchase a product and then incorporating the shipment company's confirmation of receipt. In the Amazon example, this would be the information that Amazon receives from Canada Post when the record of time of delivery is provided. Now that we understand warehouse management systems a bit more, we can understand, once you've implemented them, what are some of the domino benefits to good warehouse management. There are a number of domino effects when combining the right warehouse management system and key performance indicators, of which we've talked about. One of the most important resources in any warehouse is the amount and types of space. Significant operating costs can be saved by optimizing both flow and use of all space within the warehouse. Using UPC, QR, or other tracking methods will assist in creating a digital twin of your inventory. This digital visibility assists in real-time decision-making when supply and demand changes. More on UPC, QR, and digital tracking methods in Session 5. Similar to digital inventory visibility, a good warehouse management system helps create the foundation for better traceability of all materials in inventory. Traceability is key to successful operations and creates a flow of all inputs and outputs. Warehouse management systems, along with other key supply chain systems, integrate to assist in the decisions of how much, where, and when labor is required. When warehouse management systems are integrated or connected to your transport management system, you will get an even more accurate representation of where and when labor is needed, as it will assist in the prediction of deliveries and outgoing shipments, which may require adjustments to human resource scheduling. Warehouse management systems help tie your process flows together, and when analyzing KPIs, will assist in the recognition of bottlenecks or sections of your warehouse network that can be improved through automation. With all of the discussed improvements, the realization of these will result in better shipping. This means improved order lead time, better picking accuracy, reduced rates of return, and better receiving efficiencies, which helps achieve what every supply chain goal is: to create happier customers.